Welcome to another episode of Beyond Cost. Today I am here with Sascha Voglgsang. He is the Director of Costing and Insights at A2Mac1. A2Mac1 is the biggest automotive benchmarks service provider in the world. You're leading that field. And today we will talk about benchmarking in general, how it is shaping the industry, how it is generating insights, what are best practices, and what the future holds for such an important segment when it's about market intelligence. Thank you for coming, Sascha, and it's awesome to have you. Maybe for the viewers, could you quickly introduce yourself?
Sascha Voglgsang, Director of Costing and Insights from A2Mac1, as you said, and my pleasure to be here today.
So, Sascha, before we get into the nitty-gritties of benchmarking in the automotive industry, let's talk about you a bit. So you're a technical guy, is that correct? Could one say that? So
I would definitely say so, yes.
you studied like engineering in Germany and went into, I saw like one of your first stops was actually Fraunhofer Institute. Could you elaborate a bit on that?
So I have a bit more scientific background, so to say, studied mathematics and physics, so more theoretical actually, and then made my way into something which is more hands-on, more tangible, disassembling parts, joined a company, a small consultancy in cost engineering, where I started to take parts apart and to try to understand the technologies behind and try to explore some findings out of it.
Yeah, so that small consultancy that was based in Munich, right? And you were focused on cost engineering. That was roughly 10 years ago.
Exactly.
And how was it as someone who comes from a mathematics, physics background, getting into like basically manufacturing models of parts in the automotive industry? How was that experience for you?
So for me, it was super exciting because we were acting in different areas, right? Different industries, and you always have something new. You explore different technologies, you check green energy, solar inverters, you investigate first parts in automotive, where, it was especially in this phase where, let's say, power electronics came in the car, where you were exploring EVs and so on. So very exciting stuff. And for me, with my very analytic background, it was always nice to match this then and to cluster it by functions and try to understand how things are working and what I really can learn out of it, right? Mm-hmm. And this kind of combination of something which is more scientific with something which is very hands-on, I really enjoyed this.
And here's a question we always ask people on the podcast who got into cost engineering, because it's such a specific field. Is it something that you basically very much consciously decided to do? Or did you just kind of slip into that and you found it actually interesting?
I would say I slipped into it.
Yeah.
That was not a decision by intent, but with being very curious and taking parts apart and understanding products and technologies, one obvious dimension is what does it cost, right? Mm-hmm. And how can I make it more cost effective? How can I win more functions with smaller money, so to say, right? And this I found it very exciting. Build the most performant products, exploring cost optimization ideas, but still keeping the function, the value, and optimizing the value of the product in the end.
I see. And you already started kind of taking products apart. So benchmarking is a well-established practice, especially in the automotive industry, but not only. It reaches to other industries too. But the word benchmarking itself is actually used in a very inflationary way. Like you hear it a lot. Let's benchmark that. What's the market benchmarked on this? So could you now, from the perspective of the leading provider in that space, just explain what is really the benchmarking and why someone does it?
I think the fact that benchmarking is used in so different ways shows a bit the many dimensions which benchmarking has, right? For me, benchmarking is really to understand how a product is working, to understand which performance it has, to understand also all the other dimensions like cost attached to it. What is the cost to realize a function? What is the best technology to realize this function? And best technology already comes with many different characteristics, right? It can be driven by most efficient, it can be driven by most cost effective, it can be driven by most carbon footprint effective. right? So it has so many different dimensions, or the leanest way to produce a part. So I think benchmarking for me is really exactly this. It's investigating a part, a product, a car, along those different characteristics, categories, and functions and properties to really come to one conclusive statement and finding what is the best product.
But maybe you could elaborate a bit more on that. How do you define best product, especially in the automotive industry? So if I look at the powertrain, what are normally the questions where you as a benchmarking provider have the answers to?
I think this starts at a very high level. In the end, a car is also a product, right? A car is a product which is relevant for a user group. So what is the user group demanding? The user group for an electric car is demanding to get range, to get a certain charging speed, and so on. And those properties, of course, you need to investigate. And that's the very, very highest level. And then it comes down to how do I implement this certain functionality? How do I implement fast charging? Do I do this with separate modules, a very discrete architecture, or a more integrated way of realizing the functionality? And I think this then boils further down. Then the next question is, which components do I use? Which semiconductors do I use? And this shows a bit this funnel from, okay, I have a certain function, a certain property which I need to provide to my user, to the buyer of the car. And how do I realize this function, and what is the most cost-effective way from a system down to an architecture and a component level? And that makes it quite exciting, because especially nowadays where you have so many different implementations, where you have a lot of innovation going on, there are hundreds of different ways how you can implement this function, right? And that, I think this arbitration always makes it very exciting.
I mean, as you explain it, it's basically a very intrinsic part of the normal product development process and then overall strategy. I mean, I guess a lot of people, even not in automotive, are benchmarking. They're just not aware that they're doing that, basically. How come that such an important activity is outsourced to a central company? I mean, if you look at HMEC1 and your client list, your coverage is really amazing. You have a huge coverage and market share in the market. So what are the reasons, basically, that companies trust an external party to do that?
I would say that's driven by quantity and quality, because, as you said, benchmarking is widespread in the automotive industry. All the OEMs, they do some kind of benchmarking also internally, but they cannot manage to do the same thing across the different regions for 70 vehicles per year. So that's the quantity aspect of it. If you really want to have a conclusive coverage of the different markets, if you want to get a good understanding how players, newcomers in China are performing versus well-established legacy OEMs in Europe or in the US, then of course you need to have a certain scale in operation. That's one aspect. And the other one is, I think we go very, very structured, standardized way of analytics, but also a very granular way of doing investigations, to doing this benchmarking analytics, down to cell chemistry, so battery cell chemistry level, understanding which raw materials are used in the body in white, and it's very, very detailed. And this combination of quantity and scale, and on the other hand, very structured way of running this analysis and going very deep, I think this is a bit the winning recipe.
Yeah, and just for the viewers, you tear down 70 cars every year, part by part. That's some dimensions. So you have like multiple factories, basically, or work centers where these are teared down. They have to be all parameterized. It has to be all measured. You're there for 10 years. How can you explain how this works for someone from the outside? It's basically like an assembly line for tearing down cars. How does that assembly line look like?
Okay, I mean, essentially the process starts even earlier, because someone needs to decide which cars to disassemble, right? Yeah. What are the exciting cars which are launched in China? So it really starts very early on with this exploration of the best cars entering the market. And then we purchase those cars, is also driven by demand of customers, of course, but also our internal expertise. And we purchase the cars. We have a 3D scan of the complete product. That's how we start. We investigate which parts to take apart first and
Sorry,
to
just a question.
disassemble
So
first.
before you tear it down, you 3D scan it?
Exactly.
So the whole car goes through some kind of X-ray machine?
Not X-ray. It's visual 3D scan. So
Okay.
you have a visual setup. You need to tag all the specific parts and you scan them visually.
Yeah.
And step by step explore the full vehicle. Then you start disassembling, tearing down the first parts like doors as an example, as a complete system. And then step by step you go deeper and deeper. And that's also a bit driven by what is the exciting areas, the exciting systems of the specific car. For an EV coming in from China, everyone wants to go down to the cell chemistry and to the battery pack, obviously. But for some other cars, this might be less relevant. So, and this is how we decide, based on the technology which we see from outside, where we need to go deeper and deeper, and where we then really go to the most granular level of raw material analysis or semiconductor manufacturer identification.
I just wanted to say,
and so on.
because depending on the component, you have to look at different things, right?
Yes.
If you want to check the manufacturability of a seat with a bunch of sheet metal parts, that's very different than looking at battery cells.
Exactly. And
So-
that's also how our services are shaped.
Yeah.
So it really depends on the system, which properties you need to understand the system and to understand the product, right?
So you have the battery guys, and then you have the
Yes.
door guys and the chassis guys, and basically it's basically interesting. But this grew quite a lot, HMC1, right?
Yes. Yeah, exactly. And the one thing is really to have more cars.
Yeah.
The other dimension is also to go deeper, right?
I see.
To really go in more granularity. When we speak later about costing, I mean, one element is also which properties do you need as input to do a proper costing, right? A detailed costing and an accurate costing. And that drives a lot, let's say, the expansion then in the level of details.
And you're not the only provider on the market that does this. From our point of view, from our research, you're definitely the leading one. So why are you the best? Do you have more cars or better data, or what is the secret sauce, if you can share it?
I mean, to a certain extent, the experience, I would say. HMC1 was founded more than 25 years ago. And in this phase, I think we really learned what matters to the customer. So we have a very customer-centric approach and really discuss a lot with our customers to understand which properties do you need, what is the functions which you would like to understand, and so on. And that helped us really then to build a solid base and to build a very structured approach how we want to understand cars. And I would say this combination of building the scale then across the different regions, having the right granularity, covering the right functions, but then also really the structure of how we analyze things, I think that helped us really to be ahead of, let's say, competitors or fast followers who try to adapt the same approach.
Yeah. And the benchmark data itself is basically the context. But as I understand, you extract two things, value and cost of that data in order to be able to compare. Before we go into the cost part, you already mentioned it, like, for example, range is important for an EV, or charging time for a battery system. That's how you parameterize the value of a product is deeply dependent on the engineering team. How do you balance to come up basically with this set of values that are applicable for these different components?
I mean, for me, this starts really on the complete vehicle level, as we just discussed. And afterwards, you need to have a bit more domain expertise, I would say. Power electronics requires a different set of parameters, requires a different set of KPIs. It's more about power density, it's how compact, how integrated can you design something, while for battery, it's maybe more about energy density and so on. And there you require a certain expertise in the specific area to then define really what are the right KPIs for the respective system and domain.
And what about something that is sometimes hard to value or quantify, like design? right? That's always a point. You have like certain type of chassis, and that is important because you want certain design. How does that play in? I just imagine it's sometimes hard because there are a lot of intangible parameters when it comes to value.
Yes. I think many topics you really can cover with clear KPIs, and they are kind of objective, kind of. Or at least at least you have a certain KPI, you have your definition, and everyone understands, okay, the higher I am, it's better, the lower, it's worse. But obviously there are other categories or other KPIs which are a bit more company specific. When we speak about the interior DNA, this is specific to an OEM, right? Specific to a segment, specific to what is your target customer. So there it's less easy to define a KPIs which is then really universal. Still, there are ways how you can measure at least the functions, right?
Yeah.
Which are implemented.
I see. Now to cost. Cost is kind of a newer product that you have. You were always doing as A2Mac1 benchmarking. You're leading the costing and insights. Could you just summarize? You take the benchmark data and then you start creating bottom-up calculations, or how does that work?
Yes. I mean, in the end, this is also how I came in the company, right? So as mentioned, ECS, small cost engineering consultancy in the past. A2Mac1 was doing purely technical benchmarking in the past, but then acquired ECS for the purpose of really building up also costing and cost engineering knowledge. Since then, our vision, our focus is a bit to really, for all the cars where we analyze the technology, also evaluate the cost attached to it. Because in the end, that's an extremely important dimension to understand how cost effectively a player in US or in China is producing a certain part. And I think with coming in A2Mac1, the logic was then really to build out of this technical bill of material also a cost structure. And what you then realize is sometimes you need to add additional properties, sometimes you need to go deeper to really make this translation work. When I want to check the cost of a small part like a bracket, I mean, I need not only weight and dimensions, I also need to understand how this part is shaped, right? I need that 3D scan. Maybe I need something like the thickness of the material as well. And obviously I need to understand from which material it is produced. And I think with going in direction of really including all the cost structures of cars, we also pushed ourselves a lot of adding more granularity so that the cost result is then also really at the right level and is very accurate and uses the right base data.
So basically you're saying the first step before you can even start costing is kind of a pre-processing of the teardown data to say, okay, do I have all the information about this part through the teardown that I would need in order to do a bottom-up calculation? And you go very much detail, as I understood. So really like cycle time level, machine selection, everything.
Exactly. We need to go to this detail. Yeah.
Which comes, again, the same question when it comes to teardowns. First, scale. You do that for how many cars a year? I think
70. You mean for the technical?
For the costing.
For the costing, currently, so for this year, it's 18 cars.
Okay.
And our vision is really to cover the complete database, so the 70 cars per year.
The 70 cars per year.
Yes.
So again, doing this 70 times, I know a lot of cost engineering departments, they would see that as an extreme challenge, be able to do that. And then again, the consistency in terms of methodology, right? The same goes for the value, it goes for the cost. So how do you approach that? How do you basically have such a coverage or aim such a high coverage, still holding the quality, and then making it in a way that like matches basically the methodology in the market? So it is, so to say, consumable and everybody has the same understanding of the cost number. Of course, you could say it's one number and the higher it is, the worse, right? But the reality is not that simple, right? Because you want to really understand how granular you are. So yeah, how do you approach this? First, the scale, and second, how you make sure that the methodology you use is accepted.
Yes, and I think what you just described, I think one element which is extremely important is really the consistency. So, I mean, we speak about a database where we add 70 cars per year in terms of technical benchmark. If I compare now parts, a category like weight or dimensions, that's straightforward to compare, right?
Yeah.
And everyone understands it's consistent. Everyone understands, same assumptions and same kind of methodology which is used. For costing now, it's a bit more complex. Costing or cost is not purely objective.
Yeah.
Costing is not purely standardized. So what we first needed to develop for us is really a standardized methodology which we use across all the cars for a specific part type. When I take injection molding parts, let's say simple injection molding parts used in a center console, then of course around the globe for all my cars I need to apply the same methodology so that I achieve a consistent result. At the same time, so one thing is really consistency. At the same time, this also needs to be scalable.
Yeah.
So I can't have an expert checking all the parts 200 times to make sure, it's exactly the same and same logic behind. It needs to be standardized, but it also needs to be scalable. There in the past year, we focused a lot on really automation for let's say, costing approaches where we can automate, to give our experts more time than to look in the more advanced stuff, where it's actually sometimes even a philosophical discussion, how exactly is this part produced? So we try really to automate what we can automate and then give the experts more time to focus on what makes the difference. How is this giga casting part exactly produced?
I see.
And so on.
So kind of your solution to the scaling is first having one standardized methodology in order to bring the comparability and do some kind of delta costing. So like within your data set, everything is comparable to each other. And the second one is based on a good pre-processed teardown with structured data built in automation on that structured data and try to reproduce your knowledge. This sounds like I'm paraphrasing AI use cases. So is AI actually a big topic?
I would say it's extremely important.
Yeah.
It's really extremely important for us because, as mentioned, now this year we are at the 18 vehicles per year, but that's not the end of the story, right? Mm-hmm. We want to make 70 in a rather near future. So obviously then you need to have more automation. As we just talked, also in terms of internal consistency, that's also only one part of it, right? Mm-hmm. You also need to make sure that it matches the requirements of your customer. So it would not be sufficient that you are just consistent. You also need to make sure in terms of absolute values, it makes sense, of course, for the user.
At least is translatable.
Exactly.
Yeah.
Or is translatable. Yeah.
So, okay, any concrete things that you guys do with AI?
For us, it has a number of different use cases. So the first one is actually really internally to more efficiently produce costing data. So for parts which are maybe not purely costable with a very standardized approach, where you need to check a bit more in the details, add more properties, for example. Already today, we rely on something which we call inference agent. We try to really, out of the pictures, extract properties which are relevant to calculate the part. So that's more an early phase where we are currently at. But instead then having a cost engineer checking 100 different pictures and identifying if this part is coded or not, this can actually be done by AI, right? With this kind of inference logic. Yes. The second use case is then also to get more findings out of our data. So with having this extremely wide database, one thing is you have an expert who really assesses all the different parts, compares it, and so on. But as we have all this very consistent data at hand, the other use case is actually to extract cost measure ideas out of this benchmarking database, right? Identifying, there is maybe a solution used in one car which is very cost effective for this part. So this can be extracted as we have all this data available.
So you basically come already with the measure.
Exactly.
Of what you could do given a part based on the database you have.
So we call this cost measure ideator. So the approach is not purely focusing on doing the benchmark, handing the benchmark data over to the customers, but it's really, you also want to come with concrete ideas out of the database.
And I think one topic with AI that everybody is kind of a bit concerned is the quality of the results. And you guys live on consistent, good quality of results. This is like basically your business. So how to ensure that? Because the more you do, like when you go from 14 to 70 cars and you use more automation, you produce more results. So how to check?
I think this has many dimensions actually.
Okay.
The very first one is your data, the raw data, the base data. This needs to be super accurate, right? Yeah. You realize when you try to apply cost measure ideator and your data set is slightly inconsistent, then I mean the result which you get out of it, the idea is just, let's call it fake reality. It's not true that this part is mounted without any fastener. Let's say the AI actually helps you to also improve the quality because you realize every single inconsistency, you realize it out of the results. And that's the pure baseline. Let's say the very first important step where we made quite some steps in the past year, I would say. The second step is then you also need to govern the methodology, right? You need to have experts who understand which typical design to cost levers do you have for this part group. And those rules we need to implement, and the outcomes of the AI and the cost measure ideator, as an example, we need to govern. And that's how we see it. On the one hand, really govern the data foundation, making sure that the quality is as good as it can be. And then also to govern the engine of creating ideas and the engine of creating cost results. And that's where we need to have subject matter experts.
So basically, you guys have a very big database of cars with having them quantified in their subsystems by value and cost. Now, you're not only director of costing, but of insights too. And as I know, you do industry reports actually based on your database and the knowledge that you have. So what are like current trends from your point of view, which is kind of a unique insight because you have quantified it all? What is hot? What are directions in terms of value and function that the market is moving? And what are trends and patterns that you see for cost-effective manufacturing?
To mention just a few of them, so from a technical side, what's quite interesting is really still this trend towards more integration. So you see this in various areas. You see you go away from cell to module to pack designs in batteries. You try to come out with less parts, right? So you come up with more integrated solutions, cell to pack, or you directly have even more integrated concept, cell to chassis, and so on. So that's one clear pattern. And we see this in various different domains. So we see this in power electronics, where most of the legacy OEMs started a bit with a modular approach because the risk to fail seems to be lower. But on the other hand, they took quite a backpack in terms of cost with them, because when you go with this modular approach, when you go with a rather complex design, you add a lot of weight in terms of housing parts, but also you have a far more complex wiring and architecture attached to it. So, and there we see, let's say, the disruptors in the industry, the startups, new players from China, or some specific EV manufacturers who are just a bit ahead. And so this push of going for more integration, less parts, leaner architecture, that's a clear pattern in the industry where now the legacy OEMs try to catch up.
So just to understand, through the uncertainty of the EV sales number ramp up, legacy OEMs designed rather complex and powerful modular platforms that gave them a lot of options depending on how technology changes and numbers change.
Yes.
But that complexity is now catching them up and they're just not competitive on cost anymore?
Absolutely, yeah. That's a clear pattern that there is a cost backpack as a consequence of acting slower, taking not immediately the disruptive step, so to say, for the innovation jump, the technology jump, but more going step by step, going to a modular approach, and then step by step going forward with their platform strategies.
Yeah.
But this really has some consequences in terms of cost. That's crystal clear.
Oh yeah.
And there we see the disruptors in the industry. They just made those 2-3 steps at once, and at the same time continue to innovate every year. So I think also this concept of going for a platform and the next week launch in 7 years and so on, I think this concept is a bit outdated. There you really see Chinese players, for example, they go for far shorter innovation cycles and really innovate every year a bit with continuous improvement concepts in the end. And every year when we disassemble a BYD as an example, you always find some innovation and little steps which lead in a clear direction and a clear optimization path.
Do you have some innovations in mind on top of your head from what you saw in the last year, like needle movers, where you said, oh, wow, this is like a step forward?
Maybe not purely focusing on technology now.
Yeah.
When you look in the power electronics of BYD, I mean, one dimension is really the technology which they use, yes. Every year, starting from 2020, every year we disassemble, we analyze some BYDs, right? And every year you see some improvements. They change something here, they change something there, make a step for more integration and so on, and roll this then out across the different platforms and vehicles. But the second dimension, which is also interesting to it, is another trend in the industry. While when you look back to 2020 in the onboard charger design of BYD, they had 2% of semiconductors coming from China. Every year they increased this number, and now in 2025 we actually find that more than 60% of the semiconductors of BYD is actually coming from local suppliers. So you see this trend not only every year improving the technology a bit, but you also see improving the supply chain, localizing the supply chain, making the supply chain more stable. Also there, they follow the same principle, which shows a very consistent strategy, actually.
Okay, and is this how you think the market will move forward, basically on the technical side, more and more integration? And on the commercial side, localization of supply chains? Are these mega trends? Do you see them ending soon, or is this like we are set for the next foreseeable future on that?
I think this localization trend is a clear pattern nowadays. Has also a macro political dimension, of course, when you look also in the tariff policy in US and so on. So I think this clearly is visible in the industry to go for more localized supply chains, which actually even has a carbon footprint dimension attached to it, right? So it's interesting. That's more a side effect. But when we analyze carbon footprint, we also clearly see those dependency when you go for more localization, when you go for more localized supply chains. Obviously, it also translates in some efficiency in the carbon footprint area.
Yeah, I mean, at the end of the day, if you look at the European regulations, they treat carbon footprint and penalties on that as a tariff.
Exactly.
Really, it's nothing more than that.
Maybe just the third pattern, which we of course also see, is a bit the readiness for software-defined vehicles. So that's currently in the market also very hot, I would say. You started really with a very distributed architectures, came up with more than 100 ECUs, and in recent years, everyone aims to go for more centralization. So we have those domain-oriented architectures, domain controllers in the market already since quite some years. But now the next jump will be a truly zonal architecture and software-defined vehicle architecture. Yeah. That's also something which we observe. And also in this area, of course, different OEMs go at different speed.
How do you tear down software?
We cannot tear down the software. What we can tear down is the electronics, so the parts, the electrical architecture. We understand which part communicates with which part. So which ECU controls which actuator and so on. That's one dimension of it. But then, of course, our customers are also interested in understanding the software cost, right? Yeah. And this is what we call software cost value engineering. But there you need to work with actually more the requirements of the software, right? So we cannot disassemble the software itself, but we see, okay, this function is implemented. This is how they control the function. This ECU plays a role, this actuator, and so on. And then you can, based on the requirements, you can assess what would be the cost, the should cost of the software. That's the logic.
Maybe we should do our own talk about that. Very interesting topic. Thank you for your time. That's it for today. Sascha, for me personally, very insightful. The world of benchmarking and what you do in terms of costing and insights on top of that. Stay tuned, guys. Thank you for viewing one more Cost Beyond episode, and see you next time.
Thank you very much.